Hi, pre-algebra students. So these are the notes for lesson 7.4, extension on repeating decimals. This is kind of a tough section, so you're going to want to really listen and pay attention. The first thing we're going to talk about is the key idea. And if you really focus on this and go back to these 4 steps every time, I promise you it will make it a little bit easier. So let me kind of explain what they mean. In step 1, okay, it says write the equation x equals d. What that means is set x equal to the original decimal. Step 2 is multiply each side of the equation by a power of 10. So for example, if 1 decimal place repeats, we're going to multiply by 10. If 2 decimal place repeats, we're going to multiply by 100. If 3 decimal places repeat, we would multiply by 1,000, and so on. Step 3 is subtract the original equation from the new equation. And then step 4 is to solve for x. And we're going to do that by using inverse operations. So take a look at the examples with me, and I think this will make more sense when you see me do it. So in problem number 1, our decimal is 4/10 repeating. We have 1 place that repeats. Oh, let's actually start by first setting x equal to the original. Okay, so x is equal to 4/10 repeating. We have 1 digit that repeats, therefore we're going to multiply by 10 on both sides. So remember, what you do to one side, you have to do to the other. Now, when we say 4/10 repeating, remember, there's really just a bunch of 4s that continue on and on and on forever here. When you multiply by 10, you might remember what happens is that decimal moves 1 place to the right. So it's going to go behind the 4, but we still have all these 4s here that continue to repeat. So we're going to keep that repeating portion of the decimal. So that was step 2. Step 3 is to subtract this original. So we're going to subtract x equals 0.4 repeating. And then I'm going to just solve it like an equation. So over here, notice when I subtract 4/10 repeating minus 4/10 repeating, those cancel. The whole repeating part of the decimal just drops out. I have 4 left over. And then over here, 10x, take away 1x is 9x. And now I'm down to just a very simple one-step equation. In order to solve for x, I divide by 9. So my final answer is x equals 4/9. So you just leave that as a fraction because it doesn't divide evenly. And remember, in our directions, it told us that we just wanted our answer as a fraction in simplest form. Okay, and then this whole process also proves what we talked about with rational numbers, that anything that can be written as a repeating decimal is also considered a rational number because it can be written as a fraction. All right, let's try that again in number 2. This time, again, our original decimal is 2 7/10 repeating. Notice that we still have 1 digit that repeats. The only difference here is we do have a whole number in front of the decimal. So that's going to make our work a little bit different. So I'm still just going to multiply by 10 because only 1 place value repeats. So 10x, and again, this is just going to swoop on over. So it's 27.7 repeating, because again, you have those 7s here that just keep going on and on and on. Subtract the original. So x equals 2.7. Now, when I subtract the original, notice I'm lining up my decimal points here. That's very important. And then you can see that the 7/10 repeating minus 7/10 repeating just cancels. So again, the whole repeating part of the decimal cancels. We end up with 25. So 27 take away 2 is 25. 10x take away 1x is 9x. And then divide by 9 on both sides. So x is equal to, again, 25 does not divide evenly by 9, so I can leave it like that, although that's an improper fraction. So you may want to go ahead and rewrite that as a mixed number. So it's going to go in 2 times. 9 times 2 is 18. 25 take away 18, let's see, is 8. Check my math here. So 18 plus 3 is 20, plus 5 is 8. So 2 8/9 would be my final answer there. Okay, we're going to do 2 more together. So this time If you notice, our decimal is 2500 repeating. So again, start by setting x equal to the original. Now, this one has 2 digits that repeat. So instead of multiplying both sides by 10, I'm going to multiply by 100 on both sides. So when you multiply by 100, remember that actually moves your decimal point 2 places. So it's going to be 25. And then remember, if it's 2500 repeating, it's 2, 5, 2, 5, 5, on and on and on. So we have 25.25 with the 25 repeating still. Okay, from that, we're going to subtract the original. Again, lining up the decimal is super important. So it's 0.25 repeating. Okay, so again, notice how nicely this part works out. This whole repeating part of the decimal cancels. Okay, so I have 25 left here, and then 100 take away 1 is 99. I have 99x left. And again, one-step equation, so I divide both sides by 99. So x is equal to 25/99. Now, at this point, I would want to check and see if I can simplify. I don't think I can. Using divisibility rules will help, but I think I'm just going to leave it right like that. Okay, let's try one more of those. This time, number 4 is x equals 4 and 17/100 repeating. So again, even though there's a whole number in front of the decimal point, only 2 digits repeat. So I'm going to multiply both sides by 100. Again, this swoops over twice, and this would be 17, 17, on and on and on. So it's 417 repeating. So you still have that repeating portion of the decimal after the 417. And then our next step, step 3, is always subtract the original, which was x equals 4.17 repeating. Again, noticing I'm lining up the decimal point. The repeating part of my decimal cancels on the end, and I have 417 minus 4 is 413. And then 100x, take away x is 99x. Divide by 99, divide by 99. So x is equal to 413/99. Okay, and I'm just going to leave that. I know you can write it as a mixed number. We'll talk about that in class tomorrow, but I'm just going to leave that for right now. And let's see, down here at the bottom, I've got a smidge of space. So notice you don't have any on your own tonight, but what I want you to do is to see if, based on the work that we did today, can you make a prediction about what you think 7/10 repeating would be as a fraction? What do you think 6/10 would be as a fraction? Okay, and then do you have a prediction for, let's take one like 56/100 repeating or 85/100 repeating? Okay, so just take those and see if, based on the work that we can do, can you take those 4 decimals and make a prediction about what you think those would be as a fraction without maybe doing all of this work? Can you draw some conclusions and make some predictions? Okay, so finish up with those predictions, and that's all you have to do for tonight. And then we'll come back and talk about all of this tomorrow, and we'll practice it a little bit more together. Have a good night.